So yesterday we talked a little bit more about putting things in standard form, and we talked about the advantage to putting something in standard form is it makes it easier to find x and y intercepts. Now, does anyone remember how we find the x and y intercept? Probably not, because it's been like 2 whole days. Okay, so let's talk about it again really quickly just to review. So let's say, now we'll just put an equation in standard form to do this to make it easier. So let's say I have 3x minus 4y equals 12. Now, what we learned about x-intercepts. Does anyone remember what we know about an x-intercept? Anyone? No, that's your x value in standard form. What about an x-intercept? Okay, remember x-intercept is, if you're looking at a graph, it's where it crosses the x-axis. So remember we looked at a graph and we looked at 3 different lines and we looked at the x-intercept and we talked about the names of the x-intercepts. That ring any bells? Not so much. It's just all gone like Tuesday never happened. I know. Sad. Y'all probably want to watch the video from Tuesday tonight to refresh on it because you didn't do any practice on standard form after I retaught it. So you probably want to watch the video and make sure you know how to do it, So, the x-intercept. Well, let's look. Instead of me just telling you, let's look again. All right, if I have a graph. So there's my x and y axis. If I have a line Sorry, gotta change the color here. If I have a line that crosses through Oops, I accidentally moved it. If only I could figure out how to do that on purpose, that'd be awesome. I occasionally do something where I move things, which I would love to be able to move things. I'm just not really sure how I do it. Alright, hey look, I moved it. Okay. Sorry. Alright. So let's say I have a line. You're going to just have to ignore my little red spot because I don't know how to make that go away without erasing my line. So let's just ignore that for a moment. So let's say I have a line that goes through here. The x-intercept is this right here, right? This point. What is the name of that point? Remember, the name does not mean Bob, Sally, Joe, Larry. The name is its coordinates, its location. So what is the name of that point? James? Close. David? -3, 0, right? Remember, x coordinate first, so we're going to the left 3, up or down none. So this point is -3, 0. Alright, this is our x-intercept, right? Now, we looked at a couple other lines. Does anyone remember now, what did we find was true about all of our x-intercepts? Thomas? Okay, guys, this is important. You need to remember it, which means you should maybe write it down in your notes. And if you're not taking notes, it probably would be a good idea to be taking notes. Okay? You need to remember that the x-intercept is where your y value is 0. And we talked about the reason why that's true is if you look, anywhere it crosses the x-axis, is it going to be above the x-axis? No. So my y value can't be positive. Is it going to be below the x-axis? No. So my y value can't be negative. It's got to be on the axis, and since it's not above or below, that means its y value, which determines its height, is 0, right? Always, always, every single time, right? So if I am looking for the x-intercept, the easiest way to find the x-intercept is to make my y value 0. Well, the nice thing about having it in standard form is that if I let my y value be 0, then that means this thing just goes away, right? If y is 0, then 4 times y is 0, and 3x minus 0 is 3x. So basically, if I let y be 0, the only thing that matters is 3x. So I get 3x equals 12. And if 3x equals 12, then I can divide by 3, and I get x equals 4, right? So my x-intercept is 4, 0, right? Because remember, an intercept's a point, and a point has to have an x value and a y value. Now we picked the y value because we want it to be an x-intercept, so its y value has to be 0. If its y value is anything other than 0, then it's not the x-intercept, right? So we picked the y value, and then we figured out what the x value would have to be for that to be our y value. So this is our x-intercept. Now, the y-intercept. Now maybe, now that we've done an x-intercept, maybe somebody can help me out with the y-intercept. What do we know about the y-intercept? David? No? Delson?
It would be 0, -4y.
No? Megan? Okay. What we should know about the y-intercept is where the x-intercept is where y is 0, the y-intercept is where x is 0. Remember, it's backwards. X-intercept is y, where y is 0, y-intercept is where x is 0. Same basic reasoning behind it. If it's an y-intercept, like this point right here, is that point to the right or to the left? Neither, right? Which means it's not going to be a positive x value, it's not going to be a negative x value, it's going to be 0, right? Anyone think they can draw a line going through the y-axis where the y-intercept doesn't have its x value is 0? Well, no. I mean, if it's crossing, what's the x value here? 0, right? It's not left, it's not right. What about here?
0.
Here?
0.
Here?
0.
Here? Anywhere on this line? 0, right? So no matter what, where your y-intercept is, your x value is always going to be 0. So the easiest way to find your y-intercept is to let x be 0. Now, I'm going to have to erase this for a second. So now again, standard form is nice because the way it's set up, if x is 0, then 3x is 0, which means that this right here just goes away, right? So now be careful though. Am I left with 4y?
Negative.
I'm left with negative 4y. So my y-intercept is where negative 4y equals 12, which divided by negative 4. Did you say negative 3? I thought you said negative 4. Who was it who told me my solution? So we get our y value equals negative 3. So our solution is 0, negative 3. Which I think someone actually told me that, and I said no because I was not really looking for the solution yet. But all right, so our x-intercept for this line is 4, 0. Our y-intercept is 0, -3. Okay? Yes, Richie? No. You do the opposite operation, same number. This operation is multiplication, so I divide, but I multiplied by -4, so I have to divide by -4. All right, so once you have those 2 points, oops, sorry. Sorry. All right, once we have these 2 points, then we can graph it. So if I have this coordinate grid, my 2 points are 4, 0, so I go to the right, 1, 2, 3, 4, and up or down none, which of course makes sense because that is our x-intercept, and clearly the x-intercept should be on your x, right? And then I need to graph my y-intercept, which is 0, -3, so I go left to right none and down 1, 2, 3, and of course my y-intercept is going to be on the y-axis. So I have those 2 points. Does everyone see my 2 points? 0, -3, and 4, 0. Huh? And then the line would look like this. I actually made it a little above here. It should actually cross perfectly. Kind of hard to draw the line on this going through 2 points. But anyway, so that would be our line. And this line represents what? It represents the equation 3x minus 4y equals 12. Any number that is on this line is the solution to 3x minus 4y equals 12. If I find any other point that's on this line, now unfortunately my line's not perfectly straight, or we could do that because, again, it's kind of hard. With a ruler, it's much easier, paper and a ruler. But if I made it a nice straight line, let's see if I can actually fix it here real quick. So if I have a nice straight line, then you could actually look for other points that were on the line. For instance, let's see. This line's still not very straight. I'm going to have to use an example. I have to use a graph paper so I can show you. Anything, though, that's on the line, if it's actually a straight line, which mine is not so much, but if it is, then it will be a solution. And every single solution to that equation is on this line. Okay, so this is why this unit is called linear equations, because all of these can be represented by a line, and the line will include every possible solution to that equation. How many solutions are there to that equation? Infinitely many, right? A line goes forever in both directions, right? Which is why this line can represent all of the solutions, because this line goes forever in that direction and it goes forever in that direction, so it's going to show every possible solution. All right, now let's talk about the other way of graphing, which is graphing using, oh, why is my thing not going away? All right, so our other way of graphing is by using what's called a t-table. Now, for a t-table, this is going to be the more convenient way to have your equation written, okay, in y equals form. Now, later on in another chapter, in another section, we're going to go into slope-intercept form, and then this is definitely the way you have to have it to do slope-intercept form. But for a t-table, this is also a little easier. Now, let me show you what a t-table looks like. It's actually really, really simple, but for some reason it does get people confused a little bit sometimes. We call it a t-table because it looks like the letter T, right? It's just one line straight up and down and then another one up the top. Now, if you remember when we first started talking about functions, we talked about there are several names for x and y. X can be called the input and y can be called the output, or x is the domain and y is the range, or x is the independent variable, y is the dependent variable, okay? This equation, when we put it in y equals form, it shows very clearly that x is going to be our independent variable. In other words, we can choose x. X can be whatever you want it. If you want x to be 3, then you replace x with 3. If you want x to be -2, you replace it with -2. If you want x to be 0, you replace it with 0. Easy as that, right? Okay? Your y value is going to depend on what your x is. Okay? If I let x be 3, then y here would have to be -10. Because this equation has to be true, right? And if I let x be 3, then I have -4 times 3 plus 2. -4 times 3 is -12. Plus 2 gives me -10. So if y equals 4x plus 2 and x equals 3, then y has to be -10. Your y value depends on what you choose your x value to be. But you can pick your x value to be anything you want. Okay? Now, a couple of suggestions. Pick small numbers because you're going to have to graph some of these. And if you pick 72 as your x value, then your graph is going to have to go out to 72. And your y value might be even bigger because you might end up multiplying your x value times something and to get your y value. And your y value, you might end up with x being 72 and y being 136. So pick small values to make it easy to graph. The easiest value to use, if we have it in y equals form, by far the easiest value to use is 0. What happens if I let x be 0? Yeah, don't. Absolutely. X can be whatever you want it to be. Absolutely anything. Richie? Okay. Why negative? -4 times 0 is? Okay. It'd be +2, right? Because -4, anything times 0 is 0. No such thing as -0, actually, right? Because negative means below 0, and obviously 0 is not below 0. So you get 0 plus 2, and 0 plus 2 is 2, right? Just like on the standard form, the nice thing about letting your x be 0 is that it means that this term, which if you have it in y equals form, it'll say y equals something times x plus or minus something. Well, if you let x be 0, then that first term always goes away, which means that your y value is going to be whatever's left, right? So we get this. Now, let's look at a couple more. All right, so somebody pick. What would you like for x to be? Because remember, it can be anything, but just make sure and don't pick really big, huge numbers or you're going to make your life miserable. Jack? Okay, so Jack wants it to be 1. Good choice. So, our equation is negative 4 times x plus 1. So that means we have negative 4 times 1. Oh, I said plus 1. I meant plus 2. Sorry. So, negative 4 times 1 is? Negative 4 plus 2 is? Negative 2. So if x is 1, then y would be negative 2. All right, let's pick one more. Paris? 2. All right, so same exact thing, only now instead of having 1 as my x value, I'm going to have 2 as my x value. So negative 4 times 2 is? Negative 8. Which negative 8 plus 2 is? Negative 6. All right, so, yes?
Can you make your x value a negative number? So it could be easy.
Absolutely anything you want it to be. I mean, if I wanted x to be negative 2.75931, I could. Now, it'd make it a big pain in the rear to graph. But you can x is independent. Independent means it depends on nothing, which means it is completely free out there, whatever you want it to be. Okay? Now, that doesn't mean it's always smart to pick anything, but you can pick whatever you would like. So, yes, x can absolutely be a negative value. Yes, Allison. Maybe. All right. All right, so now let's look at graphing this. I gotta quit doing that. Not right now. All right, so let's look at how to graph this. All right, so once we have a few values, we're going to extend this a little bit. Try and make this a little bit bigger here. All right. So, your t-table is nothing more than a set of ordered pairs. This gives me 4 ordered pairs that solve this equation, right? And since this is a linear equation, what do we know about those 4 ordered pairs? Well, they are all solutions to that equation, but it's a linear equation. So what do you think is going to be true about our 4 ordered pairs?
They're all lines.
They're all on a line. Well, ordered pairs are just a point, but those 4 points should lie on the same line. Okay, so our first point is 3, negative 10, right? X value 3, Y value negative 10. So I'm going to go out 1, 2, 3 to the right, and I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right? So 3 negative 10 gives me, let's see. All right. Our next point that we have on our list is 0, 2. So I'm going left or right, none, and up 2. What is that?
So, y-intercept.
Yes, 0, 2 is also our y-intercept. All right, so there's a point that's on our line. All right, our next one we have is 1, negative 2. So I'm going to the right 1 and down 2. And then our last one is 2, -6, so I'm going to the right 2 and down 6. Now, do those 4 points look like they lay on a line? Okay. Now, one suggestion. You should always, in a t-table, find at least 3 values. Because do you make careless mistakes sometimes? Yes. Now, here's the thing. If I had another value, like let's say I put -1 on here, and then I did -1 times -4, and I said that was -4 plus 2 is -2, and I graph -1, -2, is that on the same line? No. Okay, so the nice thing is, you know if they're not on the line, that you messed up in filling out your t-table. So if they don't lie on a straight line, then that tells you somewhere you made a mistake, so you can go back and check your math. Here's the thing though, if you only do 2 points, guess what you can always do with 2 points? Make a line. Is it going to be the right line? Not necessarily. So if you have 3 points, then they really are probably only going to be on the line if it's actually the correct line. So it's always good to do at least 3 points. And I think on your homework they actually ask you to find 4. So, and then the last thing, now this is something that for some reason on my test people seem to forget. Is this the solution to -4x plus 2? No, why not? Okay, this is 1, 2, 3, 4 solutions to y equals -4x plus 2. How many solutions are there? Infinitely many. So if I tell you 4 of them, have I really shown you the solutions? No. Okay. The solution to a linear equation is a line, thus the name linear equation, right? So if you just draw 4 points, what am I going to give you? A big fat 0, because you have not shown me the solutions. You have shown me 4 of them, but 4 out of infinity is not a very good score. So make sure that the last thing you do is connect the dots, exactly. Did any of you grow up on Pee-wee's Playhouse? Probably not. I think he was gone by the time y'all were kids. Pee-wee's Playhouse. He also had movies, Pee-wee Big Adventures, and he would have a connect the dots, and he'd go, connect the dots, la 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 la. I don't know. Anytime I think of connect the dots, it makes me think of that. So, yes, somebody knows Pee-wee's Big Adventure. All right. If you haven't seen Pee-wee's Big Adventure, you should watch it. All right, and then you'll know about connect the dots. All right. So, and then anytime you're asked to connect the dots, you'll have annoying little songs going through your head. All right. So, let me make sure and cross it out. That was not a solution. All right. So, this is how we solve using a t-table. So, there's 2 options. There are 2 options for solving, or for graphing, guys. There are 2 options for graphing the solution to linear equations. Okay? One option is you can use the x and y intercept. Remember, x-intercept is where y is 0, so you just replace y with 0 and find x. And then you find your y-intercept, which is where x is 0, so you replace x with 0 and find y. Okay? The other option is to create a t-table. Now, like I said, there's a better time to do each. Okay, if I have an equation that is in y equals form, if I want to find my x and y intercepts, you can still do it. Now again, this is not an impossibility. If I want to find my x-intercept, what does that mean? That y equals 0, right? Can I replace y with 0 in this? Absolutely. If y is 0, then I have 0 equals negative 3x minus 1. The disadvantage to this as compared to when it's in standard form is this is a two-step equation I have to solve. First I have to add 1 to both sides, and then I have to divide both sides. Oops. Then I have to divide both sides by negative 3, and then I get negative 1/3 equals x. The other thing is, when things are in y equals form, is your x-intercept always going to be a whole number? Can a line cross the x-intercept somewhere other than a whole number? Yeah. So if it's in this y equals form, there's no guarantee that your x-intercept is going to be a whole number, which means it's going to make it a little bit more difficult to graph. So if I make a t-table, can I guarantee that I get whole numbers? Yeah, because I pick an x value. Negative 3 times a whole number minus 1 is going to be a whole number, right? So this one is definitely a better choice for using a t-table. Okay? If I have an equation that is in standard form, and I want to use a t-table, can I use a t-table to solve it? Yeah. But if I use a t-table, if I plug in a value for x, say x is 0, then I'm going to have 2 times 0 minus 6y equals 8. So I get negative 6y equals 8. But now, unlike when it's in y equals form where y is on one side and you just have to work out, you're going to have to be solving an equation. Whereas if I were doing standard form, it's a pretty simple process. It's just, x is 0. My x-intercept is where x is 0, so I do negative 6y equals 8 and divide by negative 6. So each one has like a better method to use. If you have it in standard form, then it's preferable to use x and y intercepts just because it's a faster process. If it's in y equals form, then it's better to use the t-table. Again, you can use either with either one. So if you're more comfortable with one than the other, you can use it. But you need to know how to use both. For the test, you'll be asked sometimes to find x and y intercepts. Sometimes you'll be asked to write a t-table or to find 4 solutions. So you need to know how to do both, but just know that there are different things that are easier with each one. So, like I said, homework for tonight is your section 8.3 practice. The first several questions are just find 4 solutions, which means you make a t-table and you pick 4 x values and solve for y. Okay? The bottom section is actually finding solutions and then graphing.
This is y